Hello, welcome to all. This demo is for the IBM Watsonx pre-conference hackathon. So we'll be demonstrating customer sentiment analysis using IBM Watsonx AI as well as IBM Watsonx Granite model. So with this, quickly I move to the short presentation and architecture. So this is our use case: customer sentiment analysis using Watsonx AI, and this is represented by Team AI Maverick, and team member is Rahul. So this is the solution architecture. So we will be inputting customer feedback, including comments, what kind of devices are purchased, which includes also satisfaction scores in the test data. So model will try to find out whether the customer is really satisfied with the purchase or not. And this is the short architecture. On the IBM cloud, we are hosting this notebook as well as we are consuming watsonx AI services, which inherently also use watsonx ML services. So through notebook, we will prompt some customer comments. We will send customer comments to the watsonx AI, and whatever the sentiment we will get, that we will analyze, and we will check the accuracy of this sentiment analysis as well. So with this, this is the solution architecture which I already discussed, and these are the benefits. Like, it's a scalable solution. It's a uh, accuracy is what we predicted is almost 90%. Productivity is also good, and this will reduces more manual effort, and which will free up analysts to do more meaningful tasks. Then what is the cost implications? Say, we'll need some initial investment. We'll need to set up watsonx AI IBM Foundation models, but I think it's a open source model, so we will not incur much cost compared to the paid model. As well as there will be API uses and cloud infrastructure cost, but there would be long-term savings as we can integrate this with CRM, and that way it will save up a lot of efforts for performing manual tasks. So what could be the next enhancements could be the model tuning, the real-time analysis, which as I mentioned, we can integrate with the CRM. It can help us to do real-time analysis. And this will be the multi-language support also we can include. So model can analyze for, say, multiple language customer sentiments. It's like, say, other than non-English language. And these are the tools what we have used, and we have used GitHub repository as resources to host this all presentation source code as well as this demo video, and we have used IBM watsonx documentation as well. So with this, I'll quickly move to the demo. So this is the notebook I have already set up in the IBM watsonx cloud. I will quickly run this installation I have run for the interest of time. I will just run this and pass my key. I will change this key post demo. So I'll quickly move ahead with this all steps. So I'm just preparing this demo. If you see, the data is uploaded in the GitHub repo. It's a CSV file. So if you see, it's showing us what is the customer service feedback and what are the satisfaction score entered for the data. So let's move ahead. As I mentioned, we are using scikit-learn model for training and testing this particular data. So we have taken half the sample size, as a sample size is almost 500 records we are using. So 250 records we are using for training and testing. So it's giving us model ID. Let us move ahead. So here we are selecting as a parameter as a greedy output, as well as we are selecting giving repetition penalty as one. So let us initialize the model. Let's get model details. Let's see it's whether it's able to follow this instruction and get us the correct prompt. So let us analyze whether it gives us the correct series. The sound system is devices, but it's a bit bulky to carry, so it has generated as a yes. But it may be like sometimes this may be customer, we can classify this as a customer may not be happy. So that's what we mentioned. The accuracy could be between 90 to 100%. So let us see how much accuracy it gives to us. Oh, if you see it's going to 8 and 8 between 9, between 8 to 9. As the sample size is only 10 samples we are selecting over here. So the accuracy is drifting between 0.8, 80 to 100%. So as I mentioned that it depends on the sample size. So let us see and what happens with say 20 sample size. Let us see. Okay. Now let us see the accuracy. Some error is there. I think I'll just check that and fix that. But that's what I mentioned that we need to change the sample size. Let's move to the sample size as 10. Check what it does now. Okay. Yeah, again 8. Let's try with 15. See, the accuracy score has increased. It has gone to 0.86%. Let's try with 20 and see what happens. Yeah, it remained between 85. So that's what I mentioned. It's revolving between point say 80, 85 to 100% or 80 to 90%, close to 90% also. Constantly we are getting the accuracy. So that's concludes our demo. Thank you for providing this opportunity for giving us this demo. Thank you. And if you see, this is the yes no result and this is the references we are using. So with this, I will conclude this demo. Once again, thank you for providing us this opportunity. Thank you.